So welcome back guys. In this particular session we will be talking about the probability, right? So I hope you guys are with me in this particular series in the biostat. In the very first chapter in the biostat we had to talk about the data. Then we had to talk about the scales of the data, right? Then we had to talk about the measures of the central tendency and the measures of variation there, where we have talked about the mean, median, mode in the measure of central tendency, right? Then we had to talk about the normal distribution curve, guys, where we had to talk about that it is having a symmetrical bell-shaped area under the curve is 1. The ends of the normal distribution curves are never touching the baseline, and in the center we are having the mean, and surrounding that we are having the standard deviation. -1 to +1 is having the 68% of standard data. Then the -2 to +2 is having the 95% approximately, and -3 to +3 was having the 98% of standard data, right? So that was kind of a quick summary of till now what we have studied in the biostat. And now in this particular topic we will be talking about the probability, right? Yes, probability. I know you are talking about that. Yes, we had studied that in the mathematics long back, but yes, here also we are talking about the probability, and I will try to talk about this probability in the particular chapter which we have just now finished, that was the normal distribution curve. So I would like to add this probability, or I would like to overlap this probability in that particular diagram of the normal distribution curve, and it will be very, very easy to understand, right? Once you have understood the normal distribution curve. So that's why if you're watching this series, watch it in this particular manner only, so that you can understand in a better way, right? So with that guys, we shall start with the probability. And the probability we are talking about, the probability can be called as p-value, right? Probability is called as p-value, and the normal range of this p-value is 0 to 1. On the minimum side it is 0, on the maximum side it would be 1. Simple. So you can see in front of you right now you are having the normal distribution curve, right? I know you must be saying, yeah, I know everything about it, but there is a thing, right? Once again guys, it's a revision for you. In the center we were having the mean, and as you are going towards the tail, most of the data is actually, you are seeing that it is there nearby the center only, nearby the mean only. As you are going towards the tail, this is called the tail side, right? This is called the tail side. As you are going towards the tail, what you can find, you will be deviating from the path, deviating from the mean. There is a standard deviation, right? So here is the, on the positive side there will be the +1, then on the negative side there is a -1, right? So we know that 68%, 95%, 99% data, we know that between -1 + 1, -2 + 2, and -3 + 3 respectively, right? Now the thing over here is that area under the curve, I told you in the previous class that it was 1 in the normal distribution curve. It is having bell-shaped, right, Gaussian distribution, right? Here I am saying that from here, from -3 to +3, right? Now this area under the curve, I am considering that as p-value. That is the probability. So I am just overlapping the probability into this particular diagram, and I am saying that it is having the range of between 0 to 1. So in total I can say that p-value is equal to 1. P-value is equal to 1 for this normal distribution curve. I told you about the zone of normalcy also guys. Zone of normalcy, I told you between -2 to -2 to +2 standard deviation, if you guys remember, and anything, any variable, any data which is coming outside this, for example more than +2 standard deviation or less than -2 standard deviation, it was considered as the abnormal Z score. And I told you that in the zone of normalcy. Here also the zone of normalcy will be present between the -2 to +2, -2 to +2. So right here also the zone of normalcy in between the -2 to +2 over here in this particular normal distribution curve, right? So that will be seen over here also, right? Okay, so we have seen that. So zone of normalcy will be here. So this is called as what? Zone of normalcy. Till now nothing new guys, except that I told you that p-value is equal to 1 for this normal distribution curve. If I am just overlapping the probability value in this normal distribution curve, the range is 0 to 1. I am introducing now one more thing over here, that is called as the confidence interval, right? What I am saying? Confidence interval. Okay, just be with me guys, it will be very, very easy to understand. Confidence interval, or you might call this as confidence limit, confidence interval or confidence limit. just wrote it in a very broad letter. Why is it so? Confidence limit or confidence interval, guys, nothing but, I told you that what amount of data was presenting between -1 to +1, that was 68% of data approximately. Between -2 to +2, it was 95%. Between -3 to +3, it was 99%. Here I am just saying that between -1 to +1, same data is present, but I am just replacing the data with the confidence limit or confidence interval. Just that's it. I'm just overlapping this data with the confidence limit or confidence interval, that's it. So here, instead of data, I can write confidence limit or confidence interval, that's it. So -1 to +1, it was having what? It was having the 68% of confidence limit or confidence interval. So I'm just briefing it over here itself, that I'm saying that between -1 to +1 standard deviation, between -2 to +2 standard deviation, and between -3 to +3 standard deviation, what would be the answer over here? You can say that almost around 68%, 95% and 98% or 99% rather, right? 99.9% rather, 99.7% standard deviation. Oh, sorry, that is about data. But now I am replacing it with confidence interval or confidence limit. So confidence interval or confidence limit. That's it, guys. Okay. Nothing has been changed. Once we have understood the concept of normal distribution curve, now it is very easy to understand the probability also. For now, probability is also same. Area under the curve was 1, p-value is 1. I have replaced the data with the confidence limit or confidence interval. There also I told you that zone of normalcy also I told you over here, -2 to +2, that was 95%. 95%. This is called as what? Normal zone or zone of normalcy, isn't it? So I told you that as well. This is called as what? This is called as the normal zone or zone of normalcy. So this also we have talked about in the previous section only, zone of normalcy, right? So very simple. Now what I told you, towards the center there will be higher chance of occurring an event, or towards the tail? Yes, towards the center. So towards the center, where will be the higher probability? Towards the center. So highest probability will be seen towards the center and lowest probability will be seen towards the tail, right? Towards the either this side of tail or either that side of the tail of the normal distribution curve, right? So here the maximum values I will be seeing towards the mean only, and the minimum or lowest probability will be seen towards the tail only. Towards the tail I will be seeing the lowest probability, and towards the center I will be seeing the highest probability, right? So I can write it over here that highest probability is seen towards the center. Highest probability is seen towards center of what? Center of normal distribution curve, and lowest probability is seen towards either side of the curve. I mean towards tail of either side of the curve. It could be left side of the curve or it could be the right side of the curve, right? But normally highest probability you will be seeing towards the center only, right? If the probability is seen between +2 to -2 standard deviation, is it a normal zone or is it an abnormal zone? It will be called as a normal zone. It will be called as a zone of normalcy, right? And they are saying that in between -2 to +2, how much of confidence interval or confidence limit? Yes, that was 95%, right? That was 95%. And here I can say that what would be the p-value? They have actually fixed the p-value for that thing. They are saying that p-value is 1 for the whole curve, and they are saying p-value is 0.05 for the normal zone. P-value, here they said that p-value or probability is the 0.05 for this thing, 0.05 for the -2 to +2, or for the zone of normalcy. For the zone of normalcy they have fixed the p-value, that is the 0.05. If I am saying right now that Z score, remember Z score is 0.08 or 0.09, then you understood that it is more than 0.05. it means it is the abnormal one. If I am saying 0.03, then you will be understanding that it is the normal one. It is the normal zone, right? It is coming in the zone of normalcy. So that is the thing over here. I mean that here, which I have highlighted in the yellow color over here, between the -2 to plus 2, that is the 95% of the data which I am highlighting over here, 95% of data over here. Here I am saying this is the zone of normalcy. Here I am saying that p value is 0.05. P value is 0.05. Anything will be presenting outside this, right? Anything will be presenting outside this, right? More than 0.05, right? More than 0.05. So that will be considered as what? That will be considered as the abnormal Z score or abnormal value, abnormal zone. Okay, got it? So that is the thing over here, right? That is for how much of confidence interval? That is for 95% of confidence interval. Remember, confidence interval, confidence limit, I have just replaced it with data. Data have been replaced by the confidence interval, confidence limit for the probability purpose. Okay, right. Now here guys, listen to me very carefully. I am gonna talk about two very important things. There could be two scenarios, either the p value could be more than 0.05, either the p value could be less than 0.05. There could be two scenarios in front of us. Either the p value could be more than 0.05, either it could be less than 0.05. What could be the things which we can see over here, right? Here I can see if it is more than 0.05, right? Because we were seeing that p value is 0.05 over here, right? If it is more than 0.05 over there, then we are seeing that then it could be the normal variant, right? P value is more than 0.05, it means this is the normal variant. Right? If we are seeing that p value is less than 0.05, it is lesser than 0.05, right? Then we are seeing that it is the abnormal value, right? It is the abnormal variant. Abnormal variant, right? Now, look, p value, if it is more than 0.05, right? If it is more than 0.05, then we are saying that it is not significant, right? It is not significant. We don't need to worry about that because it is under our control only. It is under this particular zone of normalcy only, right? So then we can say that it is not significant. It is not significant, right? But if p value will be lesser than 0.05, right? P value would be lesser than 0.05, then we are saying that it is significant value. It is significant. Okay, it is significant. If we are saying that p value is more than 0.05, right? Then we are saying that there is no effect found. And in the p value, if it is less than 0.05, we can say that effect will be found, right? Effect will be found over here. Okay, so we have talked about that what will happen to the data or what will happen to the values if the p value is more than 0.05 and if it is lesser than 0.05. So guys, one hypothesis I would like to mention over here, that name of this hypothesis is the null hypothesis. I have mentioned it in the screening chapter also, right? For the detailed purpose, you can refer to that chapter. But in the null hypothesis, what is the null hypothesis? I am having some hypothesis in my mind, right? Or there is some already hypothesis over there, right? Now that hypothesis says something. Either it could be the true statement, either it could be the true hypothesis, either it could be the false hypothesis. Now I will be doing my own research, right? And I will be comparing it with this one. If my data will be same as the hypothesis, then I will be accepting that hypothesis. That is called as the null hypothesis. I will be accepting the null hypothesis. If my data is not matching with that, then I can say that I am rejecting this hypothesis. My hypothesis is fine, right? Now in reality, that is on my result. In reality, that hypothesis might be right, or this hypothesis might be false also, right? I mean that hypothesis might be wrong also. So on the basis of that, if the p value is more than 0.05, then we are saying that null hypothesis is is accepted, right? Null hypothesis over here, that has been accepted. Okay, if I'm saying that p-value is less than 0.05, then we are saying that null hypothesis is rejected. Null hypothesis will be rejected, okay, not accepted. So if the null hypothesis has been accepted, then it is p-value more than 0.05. If it is rejected, then usually it is less than 0.05. Okay, once we have understood that, now, let's say that we are saying normal zone is 95%, 95%. From the 95%, if I'm shifting it, right, normal zone is -2 to +2 standard deviation. That is the 95% of data. If I'm shifting it, the normal zone, from 95 to 99% of data, that is between -3 to +3. Now what will happen? There is a wide range, so everything will be accepted in this wide range. So this will be called as the normal zone now. This will be called as the zone of normalcy now. Due to that, what changes we might be seeing? So previously, the data which was non-significant, for example, the data which I was seeing in this particular range or in this particular range, that was not significant for me because it was outside the normal zone. It was the abnormal zone. So that is the not significant data, right? But here, because I have just increased the range for the zone of normalcy, now this non-significant data will be becoming the significant now. What other changes might be seeing? Chances of finding an effect will be increasing now. Chances of rejection of the null hypothesis will also be increasing now if I'm increasing this particular thing, right? Okay, so now if I'm saying two scenarios over here, right? First scenario is that if I'm saying the standard deviation, or if I'm saying the zone of normalcy which was between -2 to +2 standard deviation, right, -2 to +2 standard deviation, that has been increased. That was 95% of the confidence interval or confidence limit. Now I have been increasing it from -2 to +2. I am increasing it -3 to +3. So it is now 99% of the data which is covered, 99% of the confidence limit or confidence interval has been covered. So if this is the case over there, right, that if normal zone or zone of normalcy moves from 95% to 99%, right, then what could be the changes we can see over there? First change which we shall see over here, the zone which was previously significant, now it will become non-significant, right? So the previously whichever zone was significant, now it will become the non-significant zone. So previous significant zone becomes non-significant now. Previous significant becomes non-significant now. Okay. One more thing. Chances of finding an effect over here, they will be decreasing now because everything is under normal now. 99% of the data is coming in the normal range. So chances of finding an effect outside the range, outside this range is very, very less. That's why chances of finding an effect will be decreasing now, right? So that is the thing over here. So here we can see that chances of finding an effect, will be decreasing. Okay. Chances of accepting the hypothesis will be increasing because everything is under normal range now. So I will be accepting the hypothesis only. So chances of accepting the hypothesis are increasing. Chance of accepting hypothesis increases. When we are accepting the hypothesis, when our data is coming under the normal zone, then we will be accepting the hypothesis. When our data is not coming in our range, then if it is coming outside our range, then it is that hypothesis will be rejected. So D would be that chances of beta errors will be increasing. Chance of beta errors will be increasing. if I will be talking about just reverse to that, that if I am saying that if normal zone has been shrinking from, moves from, usually it is 95%, moves from 95 to 68% now. That is, it was between -2 to +2, now I have been shrinking it to -1 to +1. Now what will happen, right? Previously the data which was actually which was actually non-significant, now it will become significant for me. The data which is coming under the normal zone, it is called as the, this data is called as the non-significant data. Now this non-significant data, right, non-significant data will be the significant now, right? So previously the data which was not significant, previous non-significant data will convert into significant data now. Previous non-significant data or confidence interval will, previous non-significant will now be significant. Okay, previous non-significant will now be significant. Next point over here, previously we were seeing that the chances of finding an effect, I would say like this, chances of finding an effect now, will it be increasing or will it be decreasing, right? Now what you did, -2 to +2, this was the range, this was the normal zone, you have just shrink it to the 68% now. So what will happen now? Chances of finding an effect, actually they will be increasing, right? Chances of finding an effect, because you are shrinking the range. So effect, you can find here and there, your results, the other kind of results might not be in the range, actually you might be finding it anywhere else. So that's why if you are finding it anywhere else, then it means you are finding some kind of effect. So chances of finding an effect will be increasing. Previously non-significant data will be actually now significant, right? I am saying that this was the curve, guys. Okay, and now the zone of normalcy was in between this one, -2 to +2. Let's say this was the zone, -2 to +2, right? I am saying that let's shrink it between -1 to +1 only, and this was the central line, this is the mean, right? Now if your result is finding, if you're finding the result here or here, now this data will become significant, because previously it was non-significant, now this data will be significant. Now the chances, right, I'm just writing over here, right, chances of, I'm writing like chances, now the chances of finding an effect will be increasing. Chances of finding an effect, it will be increasing now. C point over here, I shall write that chances of finding a alpha error will be increasing now. If you are shrinking the normal zone, then alpha error chances are increasing. If you are broadening the normal zone, then beta error chances are increasing. Chances of alpha error are increasing now. And D point over here, I am saying that chances of rejection of the null hypothesis are also increasing over here. Chances of rejection of null hypothesis, okay, they are also increasing. Okay, because I am saying that if in this highlighted area, I am just let me just write other things also, right? Let me just write other things also, that this is the -1 standard deviation, this is a +1 standard deviation. Here it will be the -2 and +2 standard deviation, right? So if you are finding the result, somewhere here, this finding is significant or non-significant now? This finding will be significant, right? And if you are finding, now I am just broadening it. If I am broadening the graph, then this finding will become non-significant, right? If I am saying that, at the same time, if I am saying that, what about the beta error? If you are chasing towards more standard deviation, then beta error will be increasing. If you are coming towards the mean, then alpha error will be increasing, right? I am saying, like, look, very, very important points, guys, very, very simple points. Look, in the center what we are having, mean, right? So if this is the mean, if you are coming towards the mean, right, then what will happen? Your alpha error chances, right, they will be increasing. alpha error chances are increasing. If you are going away from that mean, then your beta error chances are increasing, right? If you are coming towards the center, if you are coming towards the mean, your chances of accepting that hypothesis is actually increasing. But if you are going away from the mean, then your chances of rejection of hypothesis are increasing, right? So that is the nutshell story for the probabilities in the p-values. Here we have talked about, it might be some confusing to you, but here we have talked about the p-values, we have talked about the confidence limit or confidence interval. P-values I have just replaced it with the area under the curve. That was 1, 0 to 1 is the normal range over here, 0 is the minimum side, 1 is the maximum side. Here the zone of normalcy I have taken the same, minus 2 plus 2 over here. I have talked about the confidence interval, I have just replaced it, the data have been replaced by the confidence interval or the confidence limit. I have talked about also one more thing, that is the p-value. P-value is the 0.05, that is in between minus 2 to plus 2 standard deviation, that is the 95% of the confidence interval, that is showing that. If it is more than 0.05, then what could be the scene? Then if it is less than 0.05, then what could be the changes we can appreciate, that I have tried to convey over here, right? So I hope you enjoyed this one, and I will be seeing you in the next chapter. Thank you.